As mentioned before, sometimes we don't really get very nice triangles when we try to put some of these angles onto the XY plane. So we do have to approach these ones a little bit different, but they are still going to be fairly manageable for us. So we're going to look at 0. That's totally a reasonable number to want to plug into a function, so it's worth knowing what happens here. So if we plot 0, it's going to be a little bit weird, but what we're doing is starting with the positive x-axis and making our way counterclockwise a total of 0. So it just kind of stays put. Our terminal side stays right on the x-axis. Our reference angle should be 0. And there's no triangle that can really be drawn here. It's just going to be completely squished. So when we have no triangle, we don't really get to like put those sides, the opposite and the adjacent, into the picture. So we can't use that as our guide, the SOHCAHTOA. But what we do have instead is we can go up and use these formulas that we have already established. And so to use those formulas, all that we really need to do is find a point on our terminal side. So let's say here. And we can really choose any point on there. So as long as x is positive, and y is 0, it should be on that terminal side. So the point 1 and 0 works. We can find r. You can calculate it formally, but we'd have, it's just the length here. So it would be root 1 squared plus 0 squared is 1. So yeah, our hypotenuse, and maybe that's why we don't like to totally use hypotenuse, because sometimes it's not actually a hypotenuse, but that radius or measurement there is going to be 1 using the Pythagorean theorem still. And so yeah, we should be able to actually just plug everything right into the formula. Sine of 0 degrees is going to be y over r, which is 0 over 1. Cos of 0 degrees is x over r, which is 1 over 1. And tan of 0 degrees is y over x, which is 0 over 1. So these things are still completely defined, even though we don't really get triangles out of it. The behavior is still going to be consistent with the formulas at the top there. Okay, the next one, it's in radians, so I'm just going to convert it. So we'd have 3 times 180 degrees over 2, so 270. This one, again, is going to fall in kind of an ugly place. Yeah, so 270 is going to be a 180 degrees, right, plus another 90. So it actually falls right on the y-axis. And we're going to have to do the same thing. So I'm going to choose an arbitrary point on that terminal side. All that I really need now is x should be 0 since it's on the y-axis, and the y should be negative. So maybe just to mix it up a bit, I'll try -5 for this point. Yeah, like you hopefully are seeing that there is no triangle that can be made from this scenario as well. Yeah, the triangle would just be like 0 thickness, basically. It would just be all height. It'd be a straight line, pretty much. Yeah, so we should be able to go and plug everything in the formula again. I'm not going to calculate r with the formula. It is just that length, and we always want r to be positive. So the distance between the origin and that point is 5. And yeah, we're going to plug everything in. So sine of 3 pi over 2 is going to be my y over r, which is -5 over 5, which is -1. So it didn't really matter that I chose like -5 instead of -1 or -2 or -20. The distances just sort of cancel each other out, the lengths, and the ratio should be the same regardless. Cos of 3 pi over 2 will be x over r, which is 0 over 5. And tan of 3 pi over 2 is going to be y over x. In this case, there's a little bit of a snag. We actually get -5 over 0. This is undefined. There are certain tan values that are not defined, and that is a little bit of a problem. So you have to watch out for that. But yeah, so this is how we manage it if it's one of those kind of ugly. I mean, they're actually really nice angles, but they end up in an ugly place as far as how we deal with all of the other angles. So we just straight up use those formulas with the X, Y, and R.